All right, so all we're doing is putting this in our calculator, right? And seeing where the graph touches or crosses the x-axis, right? So I'm going to type it in. Morning. Morning. There it is. Okay, so how many zeros should I be looking for? 3. Do I see 3? Yes. So they are right here, right there, and right there. Okay? These two on the left in the negative area are fractions. Looks like -1.5, -2.5, just guessing. And this one looks like a whole number 4. So what I do to check is I go to my table, which is second graph, and I'm going to look here. There it is at 4. There's a 0. Y is 0 when x is 4. So that was right. Now, if you look, just go up here and look at these numbers. So this is 4, okay? But just think about something here. Okay, so you gonna listen? Okay. Look at these points here. I'm gonna get a pen going. All right. So at -3, I've got a -21. That's like down here. I'll do it in blue, let's say. Somewhere down there, further down, but down there. And at -2, it's at 6. That's here, right? So notice that at -3, I have a negative y value. At -2, I have a positive y value. That means that the graph crossed the x-axis, right? It went from a negative y to a positive. So it was moving from down here up. It crossed the x-axis. So there's a 0 between the -3 and the -2. And then if you look at -1, it's at -1 here, there's a -15 down here. So it went from a positive y value back to a negative y value, so it went back through the x-axis again. Okay, so there's a 0 between -3 and -2, and also between -2 and -1. Okay, and it's just something to think about there. At 4 it's 0, but at 3 it was a negative number, and at 5 it's a positive number. So between 3 and 5 there was a 0. If you look, 3 is at -99. If I go look at my calculator, 5 is going to be a positive something. See, 3 is a -99. It gives us the 0 at 4. That's what's nice. But then you can see the 5 is a positive y value. So it went through the x-axis. So that's something you can look at too, to kind of get an idea of where that number is, where that 0 is. Just something to think about as we move on through this stuff. Questions on that warm up? Good. All right. So if you put the polynomial in your calculator correctly, you should have gotten the correct answers for the homework. All right, so we started at 35 last night, right? All right, so you should have gotten -4, +1.5, and a +3 for 35. For 36, you get 4/3, which is 1.3 repeating, a 2 and a 5. 37, you get 1, and then they have the answers in radical form. It's -1 plus the square root of 17 over 2, and -1 minus the square root of 17 over 2. So let's put that in the calculator. All right. So -1 plus the square root of 17 divided by 2. So the decimal is 1.56. So if you had 1.6, you were right. And the other one was minus the square root of 17. Divided by 2. So a -2.6. All right? So a 1.6 decimal answer and a -2.6 decimal answer for number 37, along with the 1. And then for 39, -3/4 or -0.75, and a +1/2, which is a +0.5. Questions? Is our calculator, are we getting better at finding the zeros? Okay. Today is very, very similar, but we're not going to be able to see all the zeros like we could last night. So we're going to have to do some synthetic division today, okay, which you guys are good at, right? So the first thing, and I've already really talked to you guys about this, all right, but this is called the fundamental theorem of algebra. And it says the table shows several polynomial equations and their solutions, including repeated solutions. Notice that for the last equation, the repeated solution x equals -1 is counted twice. Okay, so they gave us 4 different polynomials. Okay, this is a first degree, which we call linear. This is a second degree we call quadratic. This is a third degree we call cubic. This is also a third degree called cubic. All right. So when it has a degree of 1, there's only one solution. When it has a degree of 2, there's only 2 solutions. When it has a degree of 3, it has 3 for both of these. Sometimes a solution is repeated, though, is what they're saying. So you can count it twice. So it's part of the 3 solutions. Okay, so that's what the fundamental theorem of algebra says. And this guy, this German mathematician, Carl Friedrich Gauss, back in the 17 and 1800s, he figured out this relationship. He proved this theorem. And that's all it says. Whatever the degree is, it has that many zeros. Basically, this last line here. Okay? If it's got a 5th degree polynomial, it's going to have 5 zeros. If it's a 3rd degree polynomial, it's going to have 3 zeros. That's what we're saying. And I've already told you guys that, right? Okay, so that's the reason this guy is the guy who figured that out. Okay, Gauss. All right, so put that in your calculator. First of all, how many zeros are we going to have? 4. Okay? So go ahead and find them and see how you do. I'm going to do it by factoring. You guys do it on your calculator.
I only got 2 as well.
All right, by now you should have seen that it crosses at -1 and -2, right?
Yeah.
You guys all saw that in your calculator?
Yeah.
Any questions?
What are the other two?
The other two you can't see, right? Okay, so they're gonna be imaginary. Okay? So, I did this by factoring. There was no GCF, it's got 4 terms, so I did grouping. I took out a GCF here of x cubed, and that left x plus 1. The GCF was 8, left me an x plus 1. So I got an x plus 1 and x cubed plus 8. So that's one of those sum of cubes we learned about last week. All right? So the cube root of x cubed was x, the cube root of 8 was 2. That's how I got those. You take the first term and square it. You multiply those together. That's how I got the 2x. But it's opposite sign of what that was. And then I squared the 2 to get the 4. Okay? So here's the 0. When I set this equal to 0, okay, that's a -1 for the 0. When I set that equal to 0, it's a -2. I got to set this equal to 0. I can't factor. Okay, there's no factors of positive 4 that add up to -2. So I have to use the quadratic formula. Okay? So I would go x equals -b plus or minus the square root. Again, this is nothing new for you guys. B squared minus 4 times a times c over 2 times a. All right? So
If we don't factor it, how do we?
get to there. I'll show you. Okay? That's a good question. All right, so that's a positive 2. And then that's a 2, right? 2 times 1. In my square root, I got -2 squared, which is 4. And -4 times 1 is -4 times 4 is -16. So that's a -12, right? So there's my imaginary, because I got a negative under the radical, right? So, do your little factor tree. What can I pull out? The 2, and since it's negative, what else? The I. So this is 2 plus or minus 2i, radical 3 over 2. So since all those are 2's, I can turn them all into what? 1's, right? So this would be 1 plus or minus I times the square root of 3. Those are the other 2. 1 plus I radical 3 and 1 minus I radical 3. Okay, that was factoring. Most of you won't do that because it's easier to do it on your calculator, right?
Yeah.
Okay, so here's what you're going to do when you only see these 2, but there's 4. Okay, you don't see all of them. You're going to do synthetic division. You're going to put -1 in your corner, and then what do we have here? We got a 1, 1, 8. We got a 0 also for the x squared. Do you guys notice that?
1, 1.
So we got 1, 1, 0, 8, 8. Because there was no x squared. So -1 times 1 is -1. -1 times 0 is 0. -1 times 0 is 0. -1 times 8 is -8. And that's what's supposed to happen, right?
Yeah.
Because the calculator told us it was a 0, so our remainder should be 0. Okay? So I did the -1, now I have to do the what? -2. So you put that here and stop at the 8, because that was a 0 there. -2 times 1 is -2. Add those. -2 times -2 is a positive 4, so we add those. And -2 times 4 is -8. We add those. Got the 0 again. All right. So remember, this started out as x to the 4th, right? After I do synthetic division once, this becomes what? X to the 3rd. After I do it a second time, it becomes x to the 2nd. Does this match that? Yeah. Okay, so that's how you're going to do it. I mean, if you're good at factoring and you wanna factor it like I did, that's fine. But you don't have to. You can put in the calculator, look at the graph and the table to make sure it's a zero, to find your zeros. Do synthetic division, and then this term here, this polynomial here, not factor it, but you solve it. A lot of times it's gonna be a quadratic like this, that's not factorable, so you have to use the quadratic formula. Okay? Questions? All right, let's try another one. All right, you guys do that one. How many zeros am I thinking? 5. Okay? So put that in your calculator and graph it so you can find your zeros. I did the graph and the table up there for you. Is that what yours is looking like?
No.
Yeah.
Then you put it in wrong.
Well, we're doing it at different times. We're all back.
Oh. Yeah, you want to yeah, so then figure it out.
You're always in a hurry there, George. Slow it down. All right, so what are you guys doing right now? You guys are doing synthetic, aren't you?
Yeah.
Which number did you use first? -1. Now, before you listen, Vince, pay attention, please. What do you notice at -1 here? What did it do? It bounced. So what have we said when it bounces? It works twice. Okay, so how many zeros do I see if this works twice? 3. Okay? So the other 2 that I can't see are the imaginary ones. So you have to use -1 twice in this problem to get it down to that quadratic. So it doesn't matter what order, you gotta use -1 twice and the 2 once. Again, do you understand why we have to use the -1 twice?
Yeah.
Because it bounced off. If it went through, it only worked once. Yes. You with me?
Yeah.
Okay? So when it bounces, that should tell you that it's going to work at least twice. Okay? Maybe it works 4 times. And then the other one works once. There's our 5. It works an even number of times. Okay?
That's what everyone was always speaking about. Speak slow. No. I don't know what you said. It was really nice. The imagery was nice. Spoke a little fast.
All right. So, also, did you remember a 0?
Yeah.
Good.
Yeah, I did. Right there next to me.
Yeah, you have to put the 0 in for the x to the 4th. If you didn't do that, things won't work out. Okay? So I started with the -1. Again, it doesn't matter. You can use any of those zeros to start. It'll still work. So -1 times 1 is -1. When I add those, I get -1. -1 times -1 is positive. I add those, I get 2. -1 times 2 is -2. I add those, -4. -1 times -4 is +4. I add those, -8. -1 times -8 is +8. So I get my 0, which is supposed to happen.
You did it more than I did it wrong.
Right. If you didn't get 0 there, you did something wrong. Either you forgot the 0, all right, or you just made a mistake if you signed or something you're adding.
Probably.
All right. I'm going to use -1 again because I know it's going to work at least twice.
Wow. That's the sound of.
Come on.
That's the sound of. I know it's
And again, you just go to the second to last number then with your line.
Oh, I added wrong.
Now, listen to this also, please. Remember, when it bounces, it works at least twice, but an even number of times, right? So it could, since there's only one other 0, I'm going to try -1 a third time because it could work 4 times. Okay? 4 is an even number, right?
Yeah.
So I'm going to try -1 again. And if I get 0 again, then -1's probably going to work those 4 times. It will work those 4 times. -1 times 1, -1, so I get -3. -1 times +3, that's 7. So that's not going to work, is it? -8 and -7 is not going to give me a 0, right?
Yeah.
So it only works twice. But the reason I'm checking that again, because this is a 5th degree polynomial, so there's 5 zeros. Okay? So since it bounced, it works an even number of times, which means at least twice. But in this case, it could have been 4 times. That's why I checked. But I noticed, once I got almost to the end, I could tell it wasn't going to work. So now I'm going to use my 2. Go back to my pen, right? And 2 times 1 is 2, so that's a 0. 2 times 0 is 0. That's a 4. 2 times 4 is 8. That's a 0. All right, I like this problem. This is a nice problem. This happens not a lot, but it happens more often than not. But I guess you see it a few times. All right. So remember, we started out. This was x to the 5th, right? So this one's 4, This one's 3, so this one's 2, right?
Yeah.
So we got our quadratic. We can use the quadratic formula. What's my A value?
1.
1. What's the B value? 0. What's the C value? 4. When the B value is 0, like this, I could write this equation as x squared plus 4 equals 0. Do I have to use the quadratic formula when it's like this? No, I can just subtract 4 and do what? Square root, yeah. So whenever the b is 0, like this example, I'm going to do it this way instead of use the quadratic formula because it's going to be a little quicker. Does that make sense? You can always use the quadratic formula. It'll still work. Still get the same answers. But whenever that b is 0, I just do this because it goes a lot quicker. Square root, what's the square root of negative 4? 2i, right? Because it's negative, right? The I comes out. Remember, when we do that method, it's plus or minus. So there's the other two. Positive 2i and negative 2i. All right? So my 5 answers, okay, for this problem are negative 1 twice, positive 2, negative 2i, and positive 2i. Those would be the 5 answers for that problem. So use your calculator to get started. It'll get, if it gets all of them, great. If it doesn't get all of them, then you're using synthetic division to simplify your polynomial. It will always simplify to that quadratic for you. So you can use the quadratic formula. Okay? Questions? That's it. You guys did good today. Thank you for paying attention.
Very good.
Alright.
Hey, Ventura.